First of all, you should know what is electricity, right? Many times you have heard about this word electricity. In your junior classes also you have read about this electricity chapter. So what is electricity? It is a branch of physics. In science we have three branches: physics, chemistry and biology. So electricity is a branch of physics which deals with the study of charges. So whenever the word electricity comes, you should remember the word charges. Okay, what are the types of charges? Positive charge, negative charges, like that. So you should remember the word charges. Electricity means charges. It's a branch of science which deals with the study of charges. So there are two types of there are two branches of electricity. What are the two types of electricity? Static electricity and current electricity. From this word static, you can understand that it means rest. So what do we mean by static electricity? It is a type of electricity or branch of electricity in which static electricity is a branch of electricity in which charges are at rest. Okay, and current, what do we understand by the word current? Current means motion. So it is a type of electricity in which charges are in motion. So you have to remember, static electricity means charges will be at rest. They will be at fixed point. For example, if you take a scale which is made up of a glass, and if you rub that scale on your hairs, and after that if you bring that scale close to some pieces of paper, what the scales will do? The scale will attract those papers, right? So that is an example of static electricity. In that, the charges will be fixed at a point. It will not flow from one place to another place. But in current electricity, the charges will flow or move from one place to another place. So that is the in current electricity, the charges will be in motion. So but in your 10th standard syllabus, according to your 10th standard syllabus, we don't have to read about static electricity. We will read about current electricity over there. So let's start our topics which we have to study in this chapter. So first of all, we should have a look on the topics which we have to study in this tutorial. So what are the topics which we have to study? Electric charge. Okay, wait, along with the symbols I will tell you, so that you will be remembering those points when we will discuss those points. Electric charge, the symbol of electric charge is Q. Electric current, symbol is I. All the things you have to write in capital. Potential difference is V. Potential difference is also known as voltage. Okay, many times you have heard in your house that voltage is low, voltage is high. Resistance and resistivity. Resistance is represented with the letter capital R, and resistivity is represented with the letter rho, with a symbol rho. This is called rho. Okay, like this we should write. Heat generated. Heat we used to write with alphabet H. Electric power, P. Then we have, these are the physical quantities about which we have to read in this chapter. After that, about Ohm's law we will read, Joule's law of heating, or it is also called heating effect of electric current, and at last we will read about the application of effect of current. So these are the topics which we have to read in this chapter. Once again I will tell you the symbols. Electric charge is represented by Q, electric current with I, potential difference V, resistance R, and resistivity with the symbol rho. Heat generated H, and electric power is P. And about these laws we'll read and its application. So let's start with our discussion. First of all, we'll start with the first physical quantity, that is called electric charge. And what is the symbol of electric charge? It is represented with the letter Q. Okay, charge, electric charge. So what is the meaning of this charge? Charge means it is a type of a particle. Charge is what? It is a type of a fundamental particle which is present in an atom. So there are two types of charges, positive and the negative charge. Okay, so charge is a fundamental particle in an atom, and there are two types of charges, positive and negative charge. Suppose we have this positive charge, and this is one is our negative charge. If the positive charge and negative charge will come close to each other, what they will do? They will attract each other. So means what we can say, unlike charges will attract each other. But if positive and positive charge will come close to each other, they will repel each other. So what we can say, that like charges repel each other. These topics you have read in your junior classes also. Like charges repel each other, and unlike charges will attract each other. So Like charges repel each other, unlike charges attract each other. What is the SI unit of charge? The SI unit of charge is coulomb, Coulomb, and its symbol is capital C. You should remember the SI unit of charge. Sometimes question is asked for 1 marks. What is the SI unit of electric charge? Then you have to write coulomb. Okay. Electrons carry a negative charge. You all know that electrons are carrying a negative charge and protons carry a positive charge. But their values is same. They will have equal and opposite charges. For example, electrons carry a negative charge of 1.6 into 10 to the power minus 19 coulomb, and protons also carry a charge of plus 1.6 into 10 to the power minus 19 coulomb, and coulomb is the smallest unit of charge. Okay, so 1 coulomb we can write as 1 coulomb is equal to 1 coulomb is equal to 6 into 10 to the power 18 electrons. Okay, so charge on 1 electron is equal to negative charge of 1.6 into 10 to the power minus 19 coulomb. So one formula we have over there, Q equals to Ne, where N represent number of electron and E is charge on 1 electron. Suppose in the question will be asked, calculate the charge for 10 electrons. Then what you will do, 10 is the number of electron, 10 into N. What is the charge on 1 electron? Charge on 1 electron is 1.6 into 10 to the power minus 19. If you will multiply those quantity, you will get the charge on 10 electrons. So this was all about electric charge. In this you have to remember that the SI unit of charge is coulomb, and this formula you should also remember, Q equals to Ne, where N is the number of electron and E is the charge on electron. Okay. Next, electric current. What is the symbol of electric current? I, capital I. And what is electric current? Current means motion, right? Current means motion and electric means charges. So what we can say, the rate of flow of charge is called current. The rate of flow of charge is called current. So what will be the formula of current? Current is equal to charge by time. Rate of flow of charge means charge by time. I is equal to Q by T. Q is the charge, T is the time. This is the first formula for your this chapter electricity, which will be used in various types of numerical. I is equal to Q by T. Current is equal to charge by time. And what is the SI unit of current? SI unit of current is ampere, AMPERE, and the symbol is capital A. Now, one instrument is also there which is used for measuring the current, and the name of the instrument is ammeter, AMMETER. And its symbol is like this. I've given the symbol like this. You can draw the symbol like this. One circle will be there. Inside that you have to write capital A for ammeter. This side is positive side, this side negative side. Like this, it is the symbol of the ammeter. In questions, it is asked draw the symbol of ammeter. Then you have to draw this like this. Or it can be asked name the instrument which is used for measuring the current. Then you have to write ammeter. Now, one property of ammeter we can read over there. Ammeter has low resistance and always connected in series. Suppose if we draw a electric circuit, suppose this is the bulb, okay? And suppose we have the ammeter over there. This is our battery. So ammeter will always be connected in series, means in the line it will be connected, not in a parallel. It should always be connected in series. Why ammeter is connected in series? This question can also be asked. It is connected in series because if we will connect ammeter in parallel, then what will happen? The circuit can burn, or the circuit can get damaged. So we cannot connect ammeter in a parallel combination. We should always connect it in a series, because if we will connect it in a parallel, then what will happen? It can burn the ammeter, or it can burn the circuit also. So this is your answer for that. Now, next physical quantity is our potential difference, and it is also known as voltage. Okay, it is also known as voltage. Potential difference is also known as voltage, and it is represented by the letter capital V. What is voltage or potential difference? It is a work done to move a unit charge from one point to another point. Work done to move a unit charge from one point to another point. So what we can write? Potential difference V is equals to work done divided by charge. Okay, to unit charge from one point to another point. So V is equals to W by Q. This is your one more formula for this chapter. V is equal to W by Q. And what will be the SI unit of potential difference? It is volt. V-O-L-T, volt. Now, what is the definition of 1 volt? This question can also come define 1 volt. What you will write? When 1 joule of work is done in carrying 1 coulomb of charge, then potential difference is called 1 volt. For example, what will be the SI unit of work? It is joule. And what is the SI unit of charge? Coulomb. So you can write this definition of volt from this relation. When 1 joule of work is done in carrying 1 coulomb of charge, then potential difference is called 1 volt. 1 joule of work. See, 1 joule of work is done to carry how much charge? 1 coulomb of charge. That is called potential difference. 1 V is equals to 1 joule per coulomb. So we can write 1 V is equals to 1 joule per coulomb. Unit of work is joule and unit of charge is coulomb. So we can write 1 volt is equals to 1 joule per coulomb. Now, what is the name of the instrument which is used for measuring potential difference? The name of the instrument is voltmeter. From potential difference V, you can remember it is called voltmeter, or from the word voltage, you can remember voltmeter. And what is the symbol? Its symbol is like this. One line at this inside the circle, you have to write V, capital V, this side positive charge, this side negative charge. And voltmeter, it is always connected in parallel with the circuit, not in series. Okay, like a meter is always connected in series in a circuit, but voltmeter will always be connected in parallel. This sentence you should remember. It has high resistance and connected in parallel. So what is the difference between voltmeter and a meter? A meter has low resistance and connected in series, but voltmeter has high resistance and will be connected in parallel. A meter is used for measuring the current, voltmeter is used for measuring the potential difference. 2 points you can write like that. Cell is the simplest device to maintain potential difference. Okay, now we have the cell like battery, that is the simplest device to maintain potential difference. Current always flow from high potential to low potential. Now how the current will flow in a circuit? It will always flow from higher potential to lower potential. For example, air also flows from higher altitude to lower altitude. Water also flows from high tank to a lower tank. Like that only, current will also flow from higher potential to lower potential. So this was all about your potential difference. You should remember it, the definition of 1 volt. This formula, V is equals to W by K, potential difference equals to work done divided by charge, and SI unit of potential difference is volt. And which instrument is used for measuring potential difference? Voltmeter. Okay. Next, now some of the symbols are given in your NCERT textbook which are very important for your exam point of view. So you should practice these diagrams for your exam. Symbols of some commonly used components in circuit diagram. These symbols are used while drawing the electric circuit diagram. For example, electric cell is represented like this. Positive side, one longer line will be there, that is for positive, and one smaller line will be there, that is for negative charge. A battery or a combination of cell. This is your electric cell. When 2 or 3 cells will combine, that we can call that a battery. For example, in this 2 cells are there, so this is called a battery. Plug or a switch open. See, you have to give one bracket like symbol, and no symbol will be there inside. That time your switch is in open position. Switch closed, then you have to give one dot over there. Wire joint like this. Two wires will be joined and it will be joined like a given point. Wire crossing without joining like this. One wire and it is crossing and it is not joining each other. Electric bulb symbol is this one. This is very easy symbol of electric bulb. Resistors or resistance, like this, zigzag lines you have to draw like this. Variable resistance or rheostat, one arrow you can give. This one is easy. Like you have to first draw the resistance and after that you have to give one arrow. That will be your variable resistance or rheostat. A meter, already I have told you, one circle. Inside that you have to give A, plus and minus. And for example, if galvanometer will be asked, then what you will do? You have to draw one circle. Inside that you have to write G. This will be positive charge and this will be negative charge. And what is the use of this galvanometer? It is also used for measuring the current, but very sensitive current or low current is measured by the use of galvanometer. Next, so you have to practice these diagrams. 1 or 2 times you will practice, then you will understand them and you can easily draw these circuit diagrams in your exams. Next, Ohm's law. It is a very important law which is generally asked in every year your board exams and your school internal exams also. So this Ohm's law is very important. Ohm's law. Okay. So what is the statement of this Ohm's law? The potential difference V used to represent with the symbol V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided that temperature remains constant. So what is the statement of this one? Potential difference V in any wire will be directly proportional to the current flowing through it, provided that temperature will be constant. So what So what you can easily write the statement of this Ohm's law by remembering this relation. What you write, potential difference across a given metallic wire is directly proportional to the current flowing through it, provided that temperature remains constant. You have to remember this one, that temperature will be always constant and potential difference will be directly proportional to the current I. For example, V proportional to I. If we will remove this proportionality sign, we'll get a constant. V is equals to IR, where R is our constant and it is known as proportionality constant, and the name of this constant is resistance. Okay, R is known as resistance and it is a constant. Using this formula, V is equals to IR, this is known as Ohm's law formula, mathematical form of Ohm's law. V is equals to IR, where V is potential difference, I is the current and R is the resistance. We can write two more formulas using this formula. We can write R is equals to V by I. For example, R will be this side and V is that side. So V divided by R. I also you can write. After that you can write I is equals to V by R. So two formulas you can write. Suppose in a question V will be given, I will be given. You have to calculate the resistance. You can calculate using this formula. Suppose in a question current will be given and resistance will be given. Then you can easily calculate the potential difference. So this formula, if you will remember one formula, you can write three more formulas using that. V is equals to IR. Then you can write for R also and for I also. Now, what is the definition of resistance? It is the property of a conductor to resist the flow of charges through it. Okay, resistance, it is a property of conductor. So what are conductors? Conductors are those substances which allow electricity or charges to flow through them. Example, metals and alloys. And what are insulators? Insulators are those substances which will not allow electricity or charges to flow through them. For example, rubber, wood, glass. Okay, so resistance, what is resistance? Is it a property of a conductor? Means it will be for conductors only to resist the flow of charges through it. Its SI unit is ohm. Okay, and the symbol of ohm is like this. You have to write the symbol of ohm like that. So what is 1 ohm? 1 ohm is equals to 1 volt divided by 1 ampere. So we can write the definition of 1 ohm over here. When potential difference is 1 volt and current through the circuit is 1 ampere, then the resistance R is 1 ohm. Okay, you can easily write the definition of 1 ohm if you remember this relation. 1 ohm is equals to 1 volt by 1 ampere. When potential difference is 1 volt and current flowing through it is 1 ampere, then resistance will be 1 ohm. So this is the definition of resistance. If we plot a graph versus potential difference and current, then what we will get? Suppose this side we have the potential difference and this side we have the current, then we'll get a straight line. VI graph for Ohm's law will get a straight line for this one. Okay, you should remember this graph also. Sometimes it may be as draw the VI graph from Ohm's law. Then you have to draw like this. Potential difference this side, current this side, and you have to draw a straight line from the origin. Next, one word over there is their variable resistance. We have seen the symbol of variable resistance in that. Variable resistance is a component used to regulate current without changing the source of voltage. Okay, it is a type of component which is used in a circuit to regulate the current without changing the source of voltage. And rheostat, what is rheostat? In electric circuit, a device called rheostat is used to change the resistance in the circuit. Both the things are same, variable resistance and rheostat is same. So they have the same function, that is to change the resistance in the circuit. They used to change the resistance in the circuit. Okay. Next, now the factors on which resistance of a conductor depend. Just now we have read about resistance, that it is a property of a conductor to resist the change of current flowing through it. So just now we have read that. Now, what are the factors on which resistance of a conductor will be depending? This is also very important question. This question is also asked. Write the factors on which resistance of a conductor depends. For this, you have to remember this formula. R will be proportional to L by A. L is the length of the conductor and A is the area of cross section. If we will remove the proportionality sign, we'll get a symbol rho. Rho L by A. And what is the name of this rho? Rho is called resistivity. It is a constant of proportionality known as resistivity. Now we'll look at the factors on which resistance of a conductor depends. As you can see in this formula, Resistance is directly proportional to the length and it is inversely proportional to area of cross section. Though those are the factors we have to write over there. Resistance of a uniform metallic conductor depends on, first point, directly proportional to the length of the conductor. It is directly proportional to the length of the conductor AL, inversely proportional to the area of cross section A, and it also depends on the nature of the material. Which material we are taking, which metal or alloys which we are taking, on that also resistance of a conductor will depend. So these are the 3 points, 3 factors on which resistance of a conductor will depend. Directly proportional to the length of the conductor, it will depend on the length. Inversely proportional to area of cross section, it will depend on area of cross section also, and it will also depend on the nature of the material. Suppose resistance is high, then if the length of the conductor will be high, then resistance will also be high. But if resistance will be high, area of cross section will be low, because they are inversely proportional to area. If area of cross section will be more, resistance will be low, and if resistance will be high, area of cross section will be low, okay, less. So these are the factors. Now, about the constant of proportionality, resistivity we'll read now. Resistivity. It is the fundamental property of a metal that resists the flow of electric current. It is also a property of material that resists the flow of electric current through it. And what is the unit of resistivity? It is ohm meter. Okay. And the SI unit of resistivity is ohm meter. Resistivity does not change with change in length or area of cross section, but it changes with change in temperature. Means resistivity does not depend on length and area of cross section, but it will depend on temperature. Okay. Range of resistivity for metals and alloys. For metals and alloys, the value of resistivity is very low, 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. You can see for metals and alloys, the value of resistivity is very low. But for glass and rubber, it is high, 10 to the power 12 to 10 to the power 17 ohm meter. Glass and rubbers are the insulators, metals and alloys are the conductors. Resistivity of alloys are higher than that of metals. Alloys. What are alloys? Alloys are formed by the combination of two or more metals, or a metal and a non-metal. Their properties is entirely different from the metal, right? So resistivity of alloys are higher than that of the metal, and they do not oxidize or burn at high temperature. So what we have read, that resistivity of alloys will be more than metals, and they will not burn or oxidize at high temperature. Because of this reason, alloys are used in electrical heating devices like iron and toaster. So one question can come from here also. Why alloys are used in electric iron and toasters, or electrical heating devices? What answer you will write? That alloys have very high resistivity and they do not oxidize or burn at high temperature. So they are used in electrical heating devices. They have high resistivity and they do not burn at high temperature. These 2 points you have to remember, and you can write the answer. Now, for making, you have seen that in the bulb, and that bulbs which we use in our homes, okay, in that bulb filaments are present inside that. Do you know from which metal that filament is made? That filament is made from a metal called tungsten. Its melting point is very high. That's why tungsten metal is used for making the filaments of the bulb. And inside the bulb, means inside the glass, some gases are present, like nitrogen or argon gases are present, to protect this tungsten, to prolong the life of the tungsten. So this was about bulb. Copper and aluminium. Copper and aluminium, you all know, these are the metals, are used for electrical transmission lines. Means in the electrical equipments or in the electrical wires, these metals are used, copper and aluminium, as they have low resistivity. So why they are used for electrical transmission lines? Because they have low resistivity. So one question can come from here also. Why aluminium and copper are used for electrical transmission lines? So what you will write? Copper and aluminium are used for electrical transmission lines because they have low resistivity. Okay, so this was all about your factors depending on conductors. Next we have resistors. What are resistors?